this video, we're going to go through complex fractions. Now, complex fractions is a fraction within a fraction. In other words, it's a fraction that also has smaller fractions in it. So here, let me just kind of scroll down. That's an example of a complex fraction there. We have two little fractions in the numerator, one in the denominator, inside of a bigger fraction. Okay, so there's a couple methods for handling complex fractions. I'm going to go through one method only, and it tends to be, in my experience, the method that at least 95% of students prefer. So the way we're going to do this is we're going to find the LCD for the smaller fractions. So that's step one. We're going to find the LCD for the smaller fractions. Then what we're going to do is we're going to multiply every term of this complex fraction by the LCD. And what that's going to do is it's going to cancel the denominators of the smaller fractions. And what we'll be left with is a normal rational expression that we will attempt to simplify if necessary. So we will simplify, oops, let me shift the screen up a little bit, simplify the remaining rational expression if it's necessary. Now we are going to take one approach that's different from these four steps, one only, and I'll show you the example that will do that. But really it's the only one that will take a slightly different approach. And I think you'll see what makes it different from the ones we're going to be working on. Okay, so let's go ahead and attempt this example here. So for this example, I'm kind of looking at the two smaller fractions, the 1 over x here in the numerator and this 1 over x squared here in the denominator. And I'm going to look for the LCD for just those two fractions. So looking at those two fractions, the lowest common denominator is going to be x squared, basically the one with the bigger exponent. Okay, so what I'm going to do is I'm going to multiply each term, including anything without a fraction, by the x squared. And what that I'm basically doing is I'm kind of multiplying everything by x squared over 1. And the reason I want to see it kind of like that is, especially for these two fractions here, what that's going to do with this top fraction is this x here is going to cancel with one of the x's in this numerator, and it's going to leave me an x. Down here in the denominator, this x squared is going to completely cancel with this x squared. So we've just done step 3. And those then are going to now, we're going to be able to simplify everything else. So this first term, multiplying the x squared times the 1 is just going to give me an x squared. Plus, in the second term, I'm left with just an x in that numerator. Technically, it's 1 times x, but it's x. Here in the denominator, the x squared times 1 is just going to be x squared. And then for this last term, that's going to just be minus 1, since the x squareds cancel, and I'm just left with 1 over 1. Okay, so now I'm looking at a regular old rational expression that I could simplify. So I can go ahead and factor the numerator. There's a GCF of x, and I'm left with x plus 1. That denominator is actually a difference of squares, so that could factor into x plus 1, x minus 1. And now I could go ahead and cancel the x plus 1, and my final answer is x over x minus 1. So let's try this again on another example. So for this one, again, I'm looking at the smaller fractions, and this time there's 4 fractions, okay? 4 fractions total. All of them are fractions. So the LCD, though, for all of them, kind of similar to the last one, it's going to be a squared. And what I'm going to do is I'm going to multiply every term by a squared. What I'm really doing is multiplying by a squared over 1. Especially with the fractions, it's kind of helpful to see that. And what that's going to do is reduce with every single denominator in the complex fraction. So in this very first term, the a squared over 1 times 1 over a squared, the a squareds are going to cancel. And I'm left with 1. On this second term, a is going to reduce with one of the a's up here, and I'm left with just a, and it's minus a. In this denominator, these a squareds are going to cancel completely, and again, I'm left with 1. And here, this one, the a is going to reduce with one of the a's. I'm left with just a single a, but it's plus 1. Now this, I can't simplify any further. There's nothing to factor. I'm not allowed to cross off things that aren't multiplied, so this would be the final answer. Okay, let's try it again. Now this is the only one that's different. You'll notice there's just a fraction in the numerator and a fraction in the denominator. So here's what makes this one different. When we have one fraction in the numerator and the denominator, what I'm going to do instead is rewrite this as a division. So I'm going to think of this as 9 over a squared. It's kind of looks a little like an a, sorry. 9 over a squared divided by 3 over a. So I'm just rewriting this complex fraction as a division. And because we've done this kind of problem before when we were dividing fractions, we know you're supposed to flip and multiply the second one. Oops. So that's 9a squared times a over 3. And then I can reduce. Since everything is in factored form, like there's nothing for me to factor, I can go ahead and simplify. So this a is going to reduce with one of the a's down here. 3 goes into 9 3 times. And I'm left with 3 over a. So only when we have one fraction in the numerator and denominator do we take this approach. Okay, now this one, they're being a little tricky by writing it with negative exponents. And you might recall, it's probably been a while since you've seen this, but a negative exponent is secretly a fraction. So if you have x to the negative a, that's really 1 over x to the a. That's what that represents, 1 over x to the a. So that's the exponent rule. What I'm going to do is I'm going to rewrite this then so that it's all written as fractions. So I'm going to rewrite this as 1 minus, okay, so the negative exponent, exponent of negative 1 is on the x only. So 3 is going to stay, and x to the 1 is going to go into the denominator. Next one, the negative exponent is just on the x. So the 10 is going to stay, and that's going to become x squared in the denominator, right? It becomes a positive once we bring it into the denominator. Okay, the bottom here is going to be a 1 plus, okay, so that's going to be 11 over x to the 1, which I'm just writing as an x, plus 18 over x squared. Okay, so there we go. Now it looks like the complex fractions we had before. Again, I'm going to find the LCD, which is going to be x squared. And I'm going to multiply each term by x squared. Now, because there's 3 terms, I'm just going to squeeze it in. I'm not going to put the over 1 because I know what's going to happen. In the next step, I'm going to cancel so that it reduces. So this very first term, nothing cancels. X squared times the 1 is just going to be an x squared. But the second term, the x and the x squared cancel. So the x here, maybe I'll do it in blue, reduces, and I'm left with a single x up here. So that leaves me with minus 3x, because there is a 3 there. I don't want to ignore that. Next term, x squared cancels completely. Oops. And that leaves me with just a 10. Oops. Computer's a little slower than my writing. There we go. Over. Okay, first term here, nothing cancels, so we're just left with an x squared. Second term, x cancels, leaves me with x. And there is an 11, so that's an 11x, and it's plus. Last term, the x squared completely cancels, and I'm left with 18. All right. So we're going to go ahead and factor this. We can use our shortcut. So two numbers that multiply to be negative 10, but add to be negative 3 would be negative 5 and 2. I'm going to go ahead and do the same thing for the bottom one here. So two numbers that multiply to be 18, but add to be 11 are 2 and 9. So this factors into, here, I'm just going to slide it over. Yeah, I'll squeeze it in. X minus 5, x plus 2 over x plus 2, x plus 9. So the x plus 2 cancels, and we're left with x minus 5 over x plus 9, which I'm going to squeeze in here onto this screen. And that's how you would do the kind of complex fractions where there's a monomial only in the denominator. In the next video, I'll show you what to do when there's a binomial. Very similar, but we'll take a little time to break up the videos.